Limit theorem. First theorem, the limit of constant c as x approaches a. C is any constant and a is any real number.
Example limit for as x approaches 2.
The answer is 4. F x equals 4 is a horizontal line, so any value of x, the output is still equal to 4.
So f of 2 is still equals 4. The limit of 4 as x approaches 2 is 4 also.
The second is the limit of x as x approaches a equals a. Example, the limit of x as x approaches 4 is equal to 4.
Limit of x is the same f of x equals x, an identity function whatever the value of input so also the value of output.
So the limit of x as x approaches 4 is 4.
The third theorem is the limit of constant c times function x is equal to c times the limit of x as x approaches a.
Example, the limit of 3x as x approaches 2 is equal to 3 times the limit of x as x approaches 2. The limit of x as x approaches 2 is 2, so 3 times 2. So the limit of 3x as x approaches 2 is 6.
The fourth theorem is the limit of f of x plus g of x as x approaches a equals the limit of f of x as x approaches a plus the limit of g of x as x approaches a. Example, the limit of 3x plus 6 as x approaches 2
is equal to the 3 times the limit of x plus the limit of 6 as x approaches 2.
The limit of x as x approaches 2 is 2 times 3 plus the limit of 6 as x approaches 2 is 6, so 6 plus 6, so the limit of 3x plus 6 as x approaches 2 is 12.
The fifth theorem is the limit of the product of functions f of x times g of x as x approaches a equals the limit of f of x as x approaches a times the limit of g of x as x approaches a.
Example, limit x times to x plus 1 as x approaches 3. So the limit of x as x approaches 3 times limit of 2x plus 1 as x approaches 3.
The limit of x as x approaches is 3 times quantity to times the limit of x as x approaches 3 is plus the limit of 1 as x approaches 3 is 1.
So 3 times quantity 2 times 3 plus 1.
Using PEMDAS we have 3 times 6 plus 1 or 3 times 7.
So the limit of x times quantity 2x plus 1 as x approaches 3 is 21. The sixth theorem is that the limit of f of x over the limit of g of x as x approaches a is equal to the limit of f of x as x approaches a over the limit of g of x as x approaches a.
The limit of 6x over 2x as x approaches 1 equals the limit of 6x as x approaches 1 over the limit of 2x as x approaches 1.
This is equal to 6 times the limit of x as x approaches 1 over 2 times the limit of x as x approaches 1.
This is equal to 6 times 1 over 2 times 1. So the limit of 6x over 2x as x approaches 1 is equal to 3.
There is a shortcut for finding limit, but not applicable at all times.
This is by using substitution.
For the basic limit of 4 as x approaches 2. But you can't substitute x here, so it is equal to 4.
Example, the limit of x as x approaches 4. Just simply substitute 4 to x, so the limit of 4 as x approaches 4.
From the limit of constant, the limit of 4 as x approaches 4 is 4.
So the limit of x as x approaches 4 equals 4.
Next, the limit of 3x as x approaches 2. Substitute to 2x. So the limit of 3 times 2 as x approaches 2, so it's equal to 6. So the limit 3x as x approaches 2 is 6.
Another example, the limit of 3x plus 6, as x approaches 2.
Substitute 2 to x, so the limit of 3 times 2 plus as x approaches 2, so the limit of 6 plus 6, as x approaches to which is equal to 12.
So the limit of 3x plus 6, as x approaches 2, is 12.